What if you are told that a secret language exists that helps decode the universe's mysteries? Yes, this language is mathematics. Mathematics is much more than just a subject taught in school. It's a fascinating universal language that transcends cultural boundaries, a language that speaks in numbers, shapes, patterns, and logic. It's the cornerstone of everything that exists, from the smallest particles to the grand design of the cosmos. It's the language of science, the building blocks of engineering, the rhythm in art, and the logic in economics. Let's start with the magic of numbers. Numbers are the most basic and crucial element of this language. They help us quantify the world around us, to measure, to compare, to understand. Think about it, from the moment we wake up until we go to sleep, numbers play an essential role in our lives. We use numbers to tell time, to calculate distances, to manage finances, to measure ingredients while cooking, and so much more. But numbers aren't just tools for measurement and calculation. They also hold profound significance. They help us uncover patterns and relationships that otherwise would remain hidden. The number 0, for example, revolutionized the world of computation. The concept of infinity stretches our understanding of the universe. The irrational number pi holds the secret to the circle, one of the most fundamental shapes in nature. In the realm of science, numbers help us understand the laws that govern the universe. In engineering, they allow us to build structures, design machines, and create technology. In arts, they bring symmetry, proportion, and harmony. In economics, they help us analyze trends, make predictions, and understand complex market dynamics. So you see, numbers are magical. They are the keys that unlock the understanding of the world we live in and beyond. They are the foundation of this remarkable language we call mathematics. But numbers are just the beginning. There's so much more to explore. The magic of numbers is just the beginning. Let's dive deeper into the world of shapes and spaces. Imagine a world without shapes or spaces. Difficult, right? That's where geometry, another fundamental concept of mathematics, comes into play. Geometry is like the architect of the universe, shaping and structuring our world in ways we often take for granted. At its core, geometry is the study of shapes, sizes, and properties of figures and spaces. These might be as simple as the square tiles on your kitchen floor, or as complex as the spiraling galaxies in the cosmos. Essentially, geometry helps us understand and navigate the world around us. It's the reason why a football is round, why a beehive is hexagonal, and why a snowflake is symmetric. It's the hidden hand guiding the patterns of the universe, from the smallest atoms to the largest galaxies. Let's consider maps. They are a perfect showcase of geometric principles. Cartographers or mapmakers use geometry to represent the round Earth on a flat surface. They calculate distances, plan routes, and even predict the impact of natural disasters. And it's not just maps. Geometry is deeply embedded in architecture. From the pyramids of Egypt to the skyscrapers of New York, the principles of geometry are at work. Engineers and architects use geometric principles to design buildings that are both visually pleasing and structurally sound. Even in art, geometry is at play. Artists use geometric concepts like symmetry, proportion, and perspective to create visually appealing and realistic artworks. A good example is the Renaissance art, where artists use geometric principles to depict three-dimensional scenes on flat canvases. Ever thought about why your smartphone screen is rectangular or why the wheels of your car are circular? Well, that's geometry at work too, ensuring functionality and efficiency. So, you see, geometry is all around us, shaping our understanding and experience of the world. It's in the buildings we live in, the art we admire, and even the technology we use. From the magic of numbers to the world of shapes, isn't mathematics fascinating? Now let's tackle the mystery of relationships in the world of algebra. Have you ever thought about how different things in the universe relate to each other? Algebra is the exploration of these relationships. Algebra, you might remember, is a branch of mathematics dealing with symbols and the rules for manipulating those symbols. These symbols, often represented by letters, are used to represent numbers and quantities in mathematical formulas and equations. But algebra is much more than just a collection of symbols. It's a way of thinking about and exploring the world around us. Fundamentally, algebra is about finding the unknown, or putting real-life variables into equations and then solving them. Sounds complicated? Well, let's break it down. Imagine you're planning a road trip. You know the distance you want to travel and how fast you plan to drive, but you want to figure out how long it will take you. This is where algebra comes in handy. By using a simple equation, you can solve for the unknown variable, which in this case is time. But algebra isn't just useful for planning road trips, it's also crucial in fields like computer programming. When a programmer writes code, they're essentially creating algebraic equations that a computer can understand and execute. Whether they're creating a new app or designing a video game, algebra is at the core of their work. And let's not forget about its applications in solving real-world problems, from calculating budgets and prices to understanding scientific data. Algebra serves as a powerful tool, helping us make sense of complex situations and make informed decisions. In essence, algebra allows us to uncover the mysteries of relationships among different elements in the universe. It helps us make sense of the unknown and understand the world in a more profound way. Algebra helps us understand the world better, but there's more. Let's uncover the beauty and aesthetics of mathematics next. Mathematics is not just about numbers, equations, and logic, it's also about beauty, patterns, and aesthetics. Let's take a look at fractals, symmetry, and the golden ratio. These are fascinating concepts that not only exist in the realm of mathematics but permeate nature and art as well. Firstly, fractals. These are infinitely complex patterns that are self-similar across different scales. They are created by repeating a simple process over and over in an ongoing loop. From snowflakes to mountain ranges, fractals can be found all around us in nature. And they are not just beautiful, their study provides us with insights into chaotic behavior and the formation of natural structures. Next, let's talk about symmetry. It's a fundamental aspect of both mathematics and biology. In mathematics, symmetry is a property of geometric shapes, equations, and functions. In nature, many organisms exhibit symmetry in their body structure, which enhances their efficiency and adaptability. Artists and architects often use symmetry in their work to create a sense of harmony and balance. Lastly, we delve into the golden ratio, a mathematical concept that has fascinated thinkers for centuries. It's a special number, approximately 1.618, that appears in various aspects of geometry, art, architecture, and nature. The golden ratio is often associated with aesthetic beauty due to its unique property of maintaining the same proportions, even when parts of the whole are added or subtracted. This characteristic has made the golden ratio a tool for achieving balance and harmony in design and composition. These three concepts, fractals, symmetry, and the golden ratio, demonstrate how mathematical principles can describe the world around us in a beautiful and profound way. They show us that mathematics is not a dry, abstract discipline, but a vibrant field that can help us understand and appreciate the beauty and complexity of the world. The beauty of mathematics is truly mesmerizing, isn't it? Our understanding of mathematics wouldn't have been possible without the contributions of some brilliant minds. Among them, Pythagoras, Euclid, Descartes, and Gauss stand as towering figures in the story of mathematics. Let's start with Pythagoras, a Greek philosopher and mathematician who lived around 500 BC. He is best known for the Pythagorean theorem, a fundamental principle in geometry that states the square of the hypotenuse of a right-angled triangle is equal to the sum of the squares of the other two sides. This theorem is still taught in schools around the world today. Then there's Euclid, another Greek mathematician who lived around 300 BC. Known as the father of geometry, Euclid's work, Elements, set a new standard for deductive reasoning in mathematics. His geometric principles have become the foundation for much of modern-day mathematics. Fast forward to the 17th century, and we find René Descartes, a French philosopher, scientist, and mathematician. Descartes is credited with the development of analytical geometry, which links algebra and geometry. He introduced the concept of using coordinates to locate points in space, a system we still use today in various fields, from computer graphics to space exploration. Finally, we have Carl Friedrich Gauss, a German mathematician from the late 18th and early 19th centuries, often referred to as the Prince of Mathematicians. Gauss made significant contributions across multiple fields of mathematics, including number theory, algebra, statistics, and differential geometry. His work has had a profound influence on the development of many areas of modern mathematics. It is these discoveries that have shaped our understanding of mathematics and its applications in our daily lives. So why is mathematics important, you might ask? Well, let's take a moment to recap what we've explored today. Mathematics, in its essence, is the language of the universe. It forms the basis of everything in nature and permeates our daily lives. It's not just about numbers, but also about shapes, spaces, and the relationships between different entities. We've delved into the fundamental concepts of mathematics, from numbers to geometry, algebra, and analysis, and we've seen how these principles like logic and problem-solving guide us in making sense of the world around us. We've also glimpsed the concrete applications of mathematics in our daily lives, whether it's shopping, cooking, time management, or navigation. And we've marveled at the beauty and aesthetics of mathematics, as seen in fractals, symmetry, and the golden ratio. Remember, mathematics is not just about solving equations. It's a language that helps us understand the world around us better.